be smart with technology. The first tip is to not type data in just because it's there. I've been talking with my students about this a lot recently, that a lot of times they'll provide the data, but then they'll also give summary statistics like the means and standard deviations, or the equation of a least squares regression line. And in many cases, they don't actually need to use the raw data. They can use the other information provided. A follow-up to that is that if they do provide both the raw data and the summary statistics, you can use those summary statistics as a double check to make sure that you've typed in the raw data correctly. That's a nice way to use that information if you do need to type in the data. The next big issue, and this is one that comes up a lot on the AP teachers community, is how to address the use of the calculator on the exam. And so there's a range of opinions and there's a range of strategies that teachers use both in their class and on the AP exam. So for now, what I'm speaking to is how things work on the AP exam. You may or may not make different choices, throughout the year in your classroom. But the bottom line for calculator notation, or what we call calculator speak, is calculator speak alone will not get you full credit. There's an example there with a binomial distribution. Typing in binom PDF 12, 0.2, 3 will not earn full credit. And what I tell my students is they need to imagine that the person grading their exam is a 60-year-old college professor who uses a computer and has never once picked up a graphing calculator. And although the grader would probably be able to figure out what each of those numbers means, it's really the job of the student or the responsibility of the student to clearly communicate the method. So if they can imagine that they're talking to somebody that's never used a graphing calculator before, they'll realize that that first line there isn't sufficient for good communication. So instead, we'd recommend either using the binomial formula, which you see 12, choose 3, and so on, or using the calculator command, but annotating your entries. Like, instead of just putting 12, put n equals 12, and p equals 0.2, and k equals 3. Those are standard statistical symbols and notation. And then, whether or not you've used a graphing calculator before, you know exactly the parameters of that distribution. The same thing would be true with number 2. The example of number 2 with normal CDF. My students love using normal CDF, especially when they're going between two boundaries like this example. It saves a lot of time, but if they just put normal CDF 90, 105, 100, 5, that will not result in full credit, even if they get the answer correct, because again, it's not good communication. So instead, students can find the z-score, draw, shade, and label a normal curve, and then find the area using the table or using normal CDF, or they can use the normal CDF command as long as the entries are annotated. So instead of just putting 90, 105, they put lower bound equals 90, upper bound equals 105, mean equals 100, and standard deviation equals 5. Now I want to piggyback for just a second on something that Darren mentioned in passing a few slides ago, and that is the difficulty of using symbols correctly. So we know that there's lots of different standard deviations that show up in our course. It could be the standard deviation of the data, of a sample, could be the standard deviation of a population, it could be the standard deviation of the sampling distribution of X bar, and all of those have different symbols. So I have my students, instead of trying to pick the right symbol, just write out the word mean, and write out, SD or STD, DEV for standard deviation. And so they're not putting themselves out there and possibly using an incorrect symbol. So the summary of this is it's perfectly okay to use technology as long as it's clearly communicated so that somebody who is not familiar with the graphing calculator will be able to understand what the student is doing.